Hello students, how are you? I hope all are fine and welcome to Narayan PU online classes. And today we are going to discuss about haloalkanes and haloarenes, the first chapter of organic chemistry. The weightage of this chapter for the PU examination is 6 marks and one 5 marks question and one 1 mark question. Total weightage for this chapter is 6 marks. And also 1 or 2 questions will come in the competitive examination. So first we will discuss introduction and haloalkanes and haloarenes. How these compounds are obtained? These compounds are obtained by the replacement of hydrogen atoms by halogen atoms in aliphatic hydrocarbons or aromatic hydrocarbons. What does it mean? Aliphatic hydrocarbons means simple I will take alkane. Alkane means I will take the simple example here ethane. Ethane formula CH3CH3. And here replacement of hydrogen atoms by halogen atom. So suppose one hydrogen atom is replaced by halogen atom, then you will get the compound is CH3 and CH2X. X means what here? Halogen atom. X means halogen atom. Means X can be fluorine, chlorine, bromine and iodine. Clear? In the same way, this is aliphatic hydrocarbon and we replace the hydrogen by the halogen. In the same way, aromatic hydrocarbons you take. What is the example for aromatic hydrocarbon? Take the benzene here. Benzene. And replace hydrogen atom by halogen atom. Then you will get the compound is haloarene. This is the X. Clear? This is which one here? Haloalkane. This is haloalkane and this is haloarene. Haloarene. Okay? The replacement of hydrogen atoms by halogen atoms in aliphatic hydrocarbons or aromatic hydrocarbons and gives respective haloalkanes and haloarenes. Okay? And in this haloalkane, the halogen atom is attached to the sp3 hybridized carbon. And here the halogen in haloarene, the halogen atom is attached to sp2 hybridized carbon. How can you identify whether the carbon is sp3 or sp2? You know that this carbon doesn't have any double bonds, all are single bonds. How many single bonds are there here? 4. 1, 2 and 2 hydrogen, 2 single bonds. Okay? And 4, so sp3. But here, and this is having double bond here. Double bond means what? sp2. Or otherwise, simple trick is there. You know that hybridization, how to calculate the hybridization means the number of single bonds, or we can say sigma bonds, plus free lone pair. Free lone pair. This is the trick how to calculate. See here, and for this carbon, in this carbon, here this carbon is having 4 sigma bonds. 1, 2 and 2 hydrogen, 2 sigma bonds. Total how many sigma bonds here? 4. And is that carbon having any lone pair? No. So that's why 0. And total 4. 4 means what is the hybridization? sp3. 1 s and 3 p. 4. Clear? In the same way, calculate hybridization here. This carbon is having how many single bonds here? 3. This sigma bonds. And pi bond is present here, but pi bond never be considered in the calculation of hybridization. So that's why how many sigma bonds are present here? 3. Is that carbon having any lone pair? No, 0. So that's why, and here 3. It is sp2. So I mentioned very clearly here free lone pair. Clear? What is that mean? Suppose I will take another one example, then you can easily understand. I will take the example here aniline. Aniline means here 2 hydrogens I will write. Hydrogen and hydrogen, you know that nitrogen is having 1 lone pair. Suppose in some examinations, competitive examination, they may ask what is the hybridization of nitrogen in aniline if lone pair on the nitrogen is not involved in the resonance. Not involved in the resonance means what it is? See now nitrogen is having how many sigma bonds here? 3 sigma bonds. 3 plus 1 lone pair. They mentioned this lone pair is not involved in the resonance, means it is a free one lone pair. So sp3. Suppose if they mention the lone pair is involved in the resonance with the benzene ring, then what is the hybridization of the nitrogen? Then you have to write the sp2. Why? Because you know that here sigma bond and lone pair are separated by single bond. It is a conjugation. If conjugation is there, there will be a resonance. So that's why these lone pairs involved in the resonance. Means now these lone pairs are not free. They are busy in where? In resonance. So that's why, and we have to take this nitrogen atom is having 3 sigma bonds, but this lone pair is involved in the resonance. It is not free. So that's why 3, it is what it is, sp2. So that's why sometimes in the competitive examination they may ask, what is the hybridization of nitrogen in aniline? The hybridization is in between sp3 and sp2. Clear? This is the, what does it mean, free lone pair. Clear? And next one. And if you take, why we have to study about these haloalkanes and haloarenes? Why we have to study? Because these halogenated compounds have wide range of applications in industries and as well as daily day and day life, in our day and day life. Yeah, so that's why these compounds are having very importance, and I will tell here some examples, then you can easily understand the applications of these compounds. And here in the NCERT textbook, that compound they have given, and chloramphenicol, this we will call chloramphenicol. This is the one compound. The structure of this compound is this is, and here NO2 group present here, and OH here, one another OH, NH, and a double bond O, chlorine. Yeah, this is the chloramphenicol, and it is used in the treatment of typhoid fever. See, very important this is. Yeah. Another compound is there, chloroquine. The compound is here, chloroquine. The structure of this compound is Cl, and there will be NH, nitrogen, ethyl group. And it is chloroquine, the structure of the chloroquine, and it is used in the treatment of malaria. It is used in the treatment of which one? Malaria. Halothane, another compound, halothane. The formula of this compound is, and here fluorine, 3 fluorine atoms on one carbon, and another carbon contains chlorine and bromine. This is halothane, and it is used as anesthetic. Anesthesia during the surgery, and this compound is used. Means anesthesia is used during the surgery so that the patient will not feel any pain during the operation. Clear? That is, we will call anesthesia. It is anesthetic. And thyroxine hormone, thyroxine, and it is produced in our body. It is a hormone, and this thyroxine, it is iodine containing hormone. If you see the structure of this compound, this is the structure. Iodine, OH, again iodine, and iodine, and here NH2 and COOH. This is thyroxine. See, this thyroxine hormone, it is which hormone? And iodine containing hormone, which is produced in our body. If the deficiency of this thyroxine causes disease called as goiter. Called as what it is? Goiter. Goiter means what? The swelling of the throat. The swelling of the throat resulting of enlargement of thyroid gland. You might have seen some pupil, and here there will be a swelling and around the throat. So that we will call as goiter. Clear? Another one compound is there, DDT, which is very, very, very important for your PU examination also. And the structure of this DDT is, and you have to remember this structure, because this compound is very important. Chlorine, chlorine, and all these are chlorine atoms. Here, this is the DDT. It is used as insecticide and also pesticide. Yeah, and these are, if you see these compounds, all these compounds are halogen containing compounds and having so much applications. Yeah? So that's why these haloalkanes and haloarenes are very important compounds. So this is the brief discussion about haloalkanes and haloarenes.